Hello, and welcome to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I'd like to introduce KYZEN's own Chelsea Jewell.
Hi, everybody. Thanks for joining us today. We are going to talk about troubleshooting a vacuum degreaser. So kind of an introduction here, when we're talking about, for this purposes, troubleshooting a degreaser, I'm referring more to, you're seeing issues with parts coming out of the machine and kind of how to trace that back to possible issues and troubleshoot what's going on there to correct it. So, we're going to talk about some common issues that are observed with parts cleaning, and then, just kind of walk through some considerations to help resolve some of those issues. So let's get started. So first and foremost, what we're going to talk about is soil compatibility. Obviously this system is designed to remove the soil, so making sure it can move through the machine properly is step number one that we look at. For this specific type of application, we're going to look at the boiling point of the soil first. These systems are going to have an onboard distillation that is able to clean that soil back out. So it's important to look at that boiling point to make sure that it's going to come out of the distillation properly. What we look at with those typically is about 220C, that we want it to be above that. And that kind of gives you a great bandwidth between the boiling point of the solvent that's in the machine and the boiling point of the soil. So this is going to give us an easier overall distillation system. It'll also give you a better bandwidth for your boil downs or that full distillation. And what this is, as far as the process goes, is when you start to see the temperature in the distillation, that boiling point, it will start to climb. And that's saying that we have more of the soil in there than the solvent. So it needs to kick in and boil that all down so that you can remove the soils from the system. A lot of times when these boil downs or full distillations are required is dependent on the machine, but it's also dependent on how much soil you're putting into it. So if it's running full production, you're running 3 shifts, you're going to be putting a lot more soils into it overall. So those boil downs may be a little more frequent. The next thing is fixture compatibility. So, obviously a lot of parts you'll have, just basket style fixtures, but as these systems have become more popular, we're getting into some very custom fixture designs. So the majority of what we see are stainless steel, but if you have a part with a sensitive surface, most of the time these parts are rotating. So, scratches or impacts to the surface may not be wanted. That may be a critical issue. So moving into a more custom designed fixture to hold that, give the part a little bit more cushion, so that you're not getting those scratches to the surface. What we've seen is both nylon and Teflon are compatible with the process. I do get a lot of questions on 3D printed materials and fixtures. And what we tend to tell people is, don't look at the melting point of that material, look at your glass transition temperature. So that's the point where your layers in the typical extruded 3D printing process, those are going to start to soften and peel apart. So, the melting point of a material may be in the high, 2 to 300 range, but that glass transition temperature could be 140 Fahrenheit, which is below, where you want it in the process. So what I like to look at is that glass transition temperature, just to make sure that you're not going to have any delamination, you're not going to have any fixture failure in the machine as parts are running. So one of the next issues we see fairly frequently is discoloration. And it could be a multiple of reasons why a part is discoloring. What I start to look for in trying to trace back where this discoloration is coming from is looking for patterns. We had a customer with a part similar to this that was, they were washing the parts in these JDAC trays. They were coming out of manufacturing, and it was just easier overall for them to stay in these trays. And they're stacked on top of each other. And what we were seeing as the parts came out is, because there's some compression, you've got surface contact in those JDAC trays, and it is causing a pattern discoloration, on the surface of the parts, just because the fluid can't get there and it can't clean in between those areas properly. So a great starting point is always, is there a pattern? Because if there's a pattern to the discoloration, you can start to trace it back and see what impact has had it. Temperature can be a factor. If you have some sensitive alloys, these machines get up to pretty high temperatures. So understanding, can that part actually take that hot of a temperature without discoloration? Certain surface conditions, those can change over time. Also the length of the time that soil's been on the parts. We've had, if parts are stored in oil for a long time and they're in a plastic bag, a lot of times you'll see where that plastic bag has been twisted and sealed. There will be kind of that same pattern on the surface of the part from storage. Understanding maybe cleaning before they go into storage is the better application, rather than letting them sit in that soil for a long time. And then just the overall storage conditions can play a role in that. If they are in open atmosphere, that can change where your discoloration is coming from. And if it's not a climate controlled area, you can have impacts there too. The next thing we see fairly frequently is part nesting or shadowing. And this is really part dependent. A lot of times this is when you're washing, a stamped, drawn, part that has some depth to it, some geometries. Those, because they're such similar shapes and sizes, they can actually fit and stack into each other. We kind of talk about, as funny as it sounds, loading your dishwasher. You don't want to stack those bowls right up against each other because it's going to prevent fluid flow. It's the same thing, for this style parts. You want, to have a little movement in the basket. So a lot of times the urge is to, with the compression lid baskets, is to fill it as full as possible and shove the lid down as much as possible to keep everything stable. What we try to say is, rather than filling them completely full, leave some room for movement. It doesn't have to be a tremendous amount of room depending on the part size, but letting those parts shift and move around each other will improve your cleaning. Typically what you see with nesting or shadowing is if there's like a drawn area, you'll have soil completely on the interior of the part, especially if those are like blind areas and there's no way for the solvent to get into it or drain. So it's like the whole side of one part will not be cleaned and the interior of another one. A lot of times that's what we see with nesting. But yeah, some movement is your friend there, is what we like to look for. The next thing is spotting. So I look at spotting a little differently than discoloration. Discoloration, you're going to have patterns, or it's going to be an overall discoloration. With spotting, you typically see, some white spots, but it's almost like droplets have dried on the surface. What I tend to look for, again, is patterns. If you're seeing the same pattern on all the parts, that could be revealing either a part defect, an impingement point, a shadowing point, those type of aspects. If it's kind of random scattered through it, check your soil compatibility. And, going back to that first thing we were talking about, look to see if a boil down is needed. A lot of times the soil has built up in your final wash stage, and that is contributing to why you see some spotting on the parts. And then once again, that movement, making sure you're not seeing that point-to-point connection, that they're really, really compressed together and it's preventing cleaning there. The next one we talk about is, just overall drying, because obviously there's some fine tuning depending on the part geometry. If you have areas with blind apertures that are difficult to drain, that whole basket is typically rotating. So if you give the part a little room to move, it will drain as it rotates around. But that's the whole, compressing those lids down as much as possible can prevent that. But a lot of times with drying, it's a factor of making sure the parts can drain. and your length of time. One thing we've looked at also is if you have a lot of small parts, you have some blind apertures, leaving an area in the center of the basket open can help with that. So rather than the solvent having to drain and dry completely in the interior of the basket, you give it another avenue. This can also help with cleaning if you're having issues there. It does, potentially reduce how many parts you can put into it, but you're also getting a better clean overall, and it's less drag out of the solvent coming out of the machine. So we want to keep as much of that material in the machine as possible. So those tactics can help keep the solvent in there and reduce your drag out. So kind of, going into a summary here, looking at your soils, making sure that that's compatible to move through the machine properly. Obviously, that's going to be the biggest factor. You're going to have a lot of times multiple soils coming in, so some understanding of making sure they come out correctly will help. Look at your fixturing. Make sure that it's as open as possible to promote draining, to promote part movement. If you have areas or parts that need some extra cushion, the plastic, the polymer type fixtures can help prevent issues with the surface. Just look and make sure that it's compatible with the whole process. That glass transition temperature will tell you how well things will survive as the first indicator. We're also more than happy to do testing if you need to understand if something's compatible or not. And then reducing the part overlap. So that nesting, the overfilled baskets, fixture shadowing, all those can contribute to discoloration and a problem with how parts are coming out clean. We like to say, the chemistry is not selective. It's very good at revealing a defect. But if you're seeing intermittent type issues, that tends to look deeper. We need a deeper look into the process, such as your baskets and fixtures. So that's kind of what we have as far as troubleshooting. We'll go into some frequently asked questions and common things that we hear about. So you're seeing intermittent discoloration. What could be causing this issue? When we hear intermittent discoloration, that is multiple baskets have been run of parts, everything looks great, and then you get to one basket and there's a handful of parts that have a discoloration or an issue. What could be causing this? As I mentioned, chemistry is not selective. It's not going to, if all parts go in equal, it's not going to change one or two in that basket. So what we start to look for is possible concerns upstream. Did these parts run on a stock that's different from a different supplier? Did they sit around for longer in the soil before they went into the degreasing process? Some understanding what stages before they hit the washer is kind of where we start to dig in and see if there's an issue there. Always checking your boil downs and understanding how the soils move through the machine. That's a good starting point too. But intermittent discoloration is typically an upstream issue is what we found. How do I check that my soil is compatible with the vacuum degreasing process? A lot of what we start is we look at the SDS. Look at your boiling points, look at what materials are listed in those in those oils, coolants, whatever they are. So we're more than happy to take a look at a soil and give you an idea of how that will do. There are lab scale distillation processes that you can do to see how everything moves through here, but a lot of times we can check the SDS and see what's going on there. And then there appears to be a drip type discoloration on the surface of a part. How do I correct this? And what we talk about as far as a drip style is that you have either a blind aperture or a deep well in a part, and it looks like something has wicked and dripped down the side of the part after cleaning. What we tend to see with this is either a partial cleaning issue to where we partially solubilize the soil. As it goes into that dryer, that material is wicking out and kind of dripping down the surface. So what we will look for is how that part's moving in the machine, if you're getting full rotation to both clean and dry the part fully. We'll look at that. But a lot of times it comes down to cycle and how the part's moving through the machine. So that is all I have for you guys today. Thank you, and feel free to reach out if you have any questions. Thanks.
Thanks, Chelsea. Thank you guys for watching this Tech to Tech session. If you would like to discuss this topic further or have any questions not answered in the session, please contact your local KYZEN regional manager or send an email to tech@KYZEN.com, and we will have someone follow up with you as soon as possible. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.